Hello students, welcome back to Organic Embers. Let's see how to predict the products P, Q, R and S in the given series of reactions and also choose the right statements from the given options. So the given molecule here is a catechol, which is a dihydroxy benzene molecule. It's a phenol molecule. So when phenol is treated with sodium hydroxide, the reaction is between the hydroxyl and NaOH because phenols are acidic in nature, so it's going to react with the base and it's going to form the salt. Since only one equivalence is used out of two hydroxyl groups, only one will react and it's going to form the sodium salt of the phenoxide ion. What about the other OH? It will remain as it is. So what is this? This is our product P. Now, the P is going to react with the acid chloride. The acid chloride is a functional group with COCl and then we have a CH2Cl over here. So many students will not understand this step because they are confused whether this oxide will attack the alpha carbon or the acid chloride carbon. Students, remember the acid chlorides are quite reactive as compared to the alkyl halides. Therefore, the oxygen will attack here and chlorine will leave as a good leaving group. Therefore, it's a nucleophilic substitution reaction and you are going to get an ester. Why ester? Because it is COO and again we have the aryl group here. That's why it's an ester. Now, what is this product? This product is Q. Let's treat this with sodium hydroxide. We still have one hydroxyl group. Therefore, again between phenol and the base, the reaction will take place and we are going to get the sodium salt like this, O minus Na plus. See, earlier we did not have any other functional group to react with. But here within the molecule there is a reactive center. Therefore, this phenoxide will undergo reaction and it will substitute the chlorine. So it's an intramolecular nucleophilic substitution reaction. Then what we are going to get? We are going to get a bicyclic product like this. Like this. Right? So this will be our product R. How do I know this? Because remember, whenever we have a reactive center, right, within the molecule, then intramolecular reactions are more favored. You have to remember this. This is one tip I'm giving you. The second tip is that, say, let's assume you don't know this reaction, okay? And then if you treat this with lithium aluminum hydride, then you might not get the favorable products what are given here, right? You will be somewhat stuck. Say this hydride, if it attacks here or maybe replaces chlorine, then what? You will not have the favorable products. So then you have to go ahead and think about this intramolecular cyclization reaction, right? So now let's move on to the next one, lithium aluminum hydride. Lithium aluminum hydride is a strong reducing reagent and it can reduce the esters. And the hydride ion here, it's acting as a nucleophile and it will attack the ester CO and this bond will break. It's quite easy to break this bond now. So what happens? It will become O minus. What about here? This will be ether. Ether will not react with the lithium aluminum hydride. You have to remember that. All right. So then we have CH2. This is the CH2. And what about here? COH. And it is an aldehyde. We know that aldehydes are further susceptible to undergo reduction with lithium aluminum hydride. So what happens? Further it will undergo reduction means you are going to get an alcohol. So CH2, CH2OH like this. What about here? Here it will become again phenol because we are using the acidic medium or water which will convert it to further a phenol. So OCH2, CH2OH means we are getting ether and alcohol. And this is our final product S. Okay. So now let's go through the statements given here. Q is a bicyclic ester compound with the ether. So where is Q? Q I have written like this. So this is not correct. Okay. A is wrong. Let's check for B. S is, what is S? So this is our S. There is a OH, O, CH to CH to OH. This is absolutely correct. Let's check for option C. Q is. What is Q? Let's see here. O, CO, CH to Cl. This part is correct. Yeah, OH. This is also correct. So option C is also correct. Let's check for R. R is, so we have this benzene and the cyclic ester and the ether. This is also correct. So the right options are B, C, and D. Students, I'm going to give you one more trick here. If you are stuck somewhere in the reactions, right, you don't know what products are formed, I always suggest to go through the options once, because many of the times the options will give you the right answer. You can do the retro method. Retro method means you can reverse, you know the product, and then you keep going back and check what are the reactants possible, right? So this is how you have to solve series of reactions. And if you still have any questions on this, you can comment your doubts in the comment section. Thank you for watching this video. And if you have not subscribed to the channel, please do subscribe and support me.